In this lesson, we're going to be covering how to create assembly constraints. We're going to be talking about degrees of freedom, and then we'll also come back and we'll talk about how to edit those assembly constraints. The file that I have open is called assemblyconstraints.iam, and it can be found in your Chapter 6 exercise folder. So I just have a couple basic components placed into this assembly. So I have my base component, which you'll see is grounded, so that's the component that is not going to move. All of my other components, I can move them around just by clicking and dragging on them. But before we start applying assembly constraints, let's talk a little bit about degrees of freedom. A degree of freedom is basically going to be broken into translational and rotational. From the View pull-down menu, slide on down and we're going to click on Degrees of Freedom. Control-Shift-E is your shortcut key. And you'll notice is when I've done that, I have these arrows appearing on each of the parts. So you can see the straight arrows, those are my translational, meaning that the components can move in the X, Y, and the Z. And in this case, they can also rotate about the X, Y, Z. So as I spin the part around, you can definitely see those. As we apply these assembly constraints, these degrees of freedom will be removed. So what I'd like to do is let's just take this plate and we're going to assemble it to this plate. Now before applying any assembly constraint, have an end game in mind, meaning where will this plate go? Do I want the top two planes to be flush to one another? Should they be mated, meaning that they'll sit on top of each other? And all of that will help determine which assembly constraint you will apply. Now let's start by going to the assembly panel, and if we slide on down, we're looking for the constraint tool. It is the shortcut letter C. And in the dialog box, in this lesson we're just going to be talking about the basic assembly constraints. In other lessons we'll come back and talk about the motion and the transitional. So the first constraint is a mate constraint, and that's a very powerful tool. And what we're going to be able to do with this is I move my cursor around, you'll see that I can select planes, I can select an edge, and if I come near an endpoint and I let the select other tool come back up, I can select either the edge or the point as well. So we'll just work through a couple different scenarios here. In this case I'm going to take this top plane and then I'm going to slide back over and I'm going to select the top plane of this second plate. So hopefully you heard that click in the background. That was telling me that assembly constraint was applied, or previewing it I should say. At this point I can change the offset value if I wanted to. So in this case I would have 10 millimeters in between them. But while we're looking at it from this angle here, you can see from the solution side I have a mate. And in this case it's showing me that both the arrows that I selected on those faces, also referred to as surface normals, they were both pointing up. In this case when I applied them, they are both going in towards each other. If I changed it to a flush condition, the components will now be sitting on top of each other. And in this case let's also change that back down to a value of 0 so it makes more sense. So in this case they are definitely flush. I'm going to go ahead and click on apply. And for now I'm just going to cancel that just to show that I can take these components and move them around. And Inventor is honoring that constraint, even though sometimes it appears that it's not. If I rotate the view around, you can see that those planes are still flush with each other. Again, I'm just going to hit the letter C to get to my constraint. And again, let's do a mate. But in this case I'm going to go directly to flush, pick those two planes, click apply, and then again if I just cancel out of that, you'll see that that second plate is moving back and forth, and I'm now down to 1 degree of freedom in regards to that. So if I come back and do one more assembly constraint, in this case we'll do a mate, select that plane, and I can spin the part around, or again just use that select other tool, and in this case we'll go back and apply that, click OK, and you notice my degrees of freedom are removed from that second plate. So if I try to drag it, you'll notice we get the no or the can't symbol, or in this case I just cannot move that component, it's locked down. Now if I select on that component, you'll see that it'll highlight in the browser. Sometimes it may not necessarily be as clear. So if you move your cursor over a given component, you right click. Here, let me slide this up here so we can see it kind of getting cut back off. And slide on down and it says Find in Browser. It'll take you right to that in the browser. So in this case there's only 4 components, not real difficult. But if you had hundreds and hundreds of components in your browser, it'll go back and locate those back in there for you. So what I'm going to do in this case is I'm going to go back and just delete those 3 assembly constraints by selecting them with the Control key held down and right click delete. And you can see that the constraints were removed and that second plate is free to move. Let's take a look at some of the other options here. So if I go back and apply the assembly constraint tool again, let's start that up. Again from the mate. In this case, let's go back. I'm going to just let it select other and grab that point. And let's go to that bottom point as well. Going to apply that. And just so you can see what happens here. So now as I drag that component, it's held at that point, but as you can see it's free to move in any other direction that it wants. I'm going to undo that. So that constraint has been removed. And again, we'll start up the constraint tool. Again, we're still in the mate option, just showing a couple different scenarios here. In this case, what I'm going to do is I'm going to select the 2 edges. And we'll see if I can select other through to that bottom edge. Apply that. And what I'm going to do now is I want to align both of these planes back up. So I'm going to go with a flush condition. Apply that. So if I cancel out, you'll see that it's showing me that it has 1 degree of freedom, that it can rotate. And as I drag that, you'll see that is definitely the case. So again, if I go back to my constraint tool, let's take a look at the angle. So in this case, what I'm also going to do before I apply that is that there's this option here called Predict Offset and Orientation. With that checked, and I'm going to go back here and I'm going to select 2 planes. It will default to the angle of those 2 planes. Otherwise, it would have defaulted back to 0. So in this case, with the angle, let's change that to 25. And you'll notice that it is definitely now at 25 degrees. We have 2 different solutions that are available. The directed, and think of the directed as going to be the right-hand rule to determine which is going to be the positive and the negative. And then we have undirected, and you would use the undirected if the value could change while you were going to drive that constraint or kind of drag it around. So in most cases, the directed angle is going to be exactly what we want. So again, go ahead and click on Apply there. And again, that component is locked down into place. Let's take a look at the next constraint. And that's going to be a tangent option. And in this case, maybe I'll grab one of these pins. And I want that pin to be tangent to this outside plane right there. Apply that. And before I apply, you'll see that I have 2 different scenarios here. Do I want them to be on the inside or on the outside, which is the default here? And let's apply one more mate constraint. So you can see as you are making these assembly constraints, you're going to try to use a whole bunch of different options. You'll also notice in this case I had the Predict Offset on. So I'm going to change that back to 0. You're always getting that preview, which is really nice. So now, let's cancel out of that dialog box. And if I take that pin and drag it, I can't move it to the outside because it's always being tangent to that plane, but it is seeing that plane as though it's going infinitely out. So I can't have it go around the bend here. It's just going to continue to go straight. So that's a tangent constraint, but it doesn't necessarily have to be just a flat plane. This could be circular in nature, and in this case that pin would have followed that as well. The last portion of the constraint that I want to start talking about here is going to be how do I go back and make this pin fit into that hole. There's a couple different ways of doing this, and I'm going to do it the long way first. I'm going to use the mate option, and I can go back and I can select the cylinder, and you'll see that I can select the face or the center line. So I'm going to select the center line, and if I scroll back over to that circular hole, go back and click apply. And of course in this case I could also go back and do a mate with that, with an offset. In this case you'll see that it's at -7. And what if we did -10? You'll see that it's changing the values. Click on apply. And in this case you'll notice that the pin can rotate with my degree of freedom. And if I'm okay with that, I can just leave that. Inventor doesn't force us to fully constrain that part. Now what I'm going to do is I'm going to drop in one more pin, and a nice easy way to do that is just click and drag on the component that you want to place that's already there from the browser, drag it back in. So I went through by applying that mate constraint, but there's an easier way to do that. In this case I'm going to use the insert constraint, and with the insert constraint I'm going to select two circular planes. So I want to make sure that I select the correct one, and by doing that, basically what it's doing, it's removing 5 degrees of freedom because it's taking both of those circular faces and aligning them to the planes and also centering them. So in this case, if I go ahead and click on apply, I am now also down to 1 degree of freedom. So if I come back down here, let's say I wanted to make a change, because right now if I slide this over, you'll see that the pin is on the opposite side of the hole that I really wanted. So if I expand that part in the browser, I can right click on that insert, I can do an edit, and what the edit's going to allow me to do is this is where I can go back and reselect planes and faces. So in this case I'm going to come back here with that first one, reselect that, and I'm going to pick on the bottom plane. And now I'm also going to reverse the direction, so it's going to go up like so. So we can always go back and make changes pretty quick, pretty easy to do. So that looks pretty good, but sometimes you'll also want to go back and you'll want to edit the value. So in this case that insert constraint had a value of 0. If I double click on that, the dialog box will pop back up. In this case, let's just change it to 5. And you see that it offset that value by 5.